Hi, this is Paul. We're doing Leetcode must-know interview questions. Today's challenge, to sum 2. Input array is sorted. The to-sum coding problem, it's a pretty common coding interview question. It hasn't been in the Leetcode list yet, so we're at to sum 2. Input array is sorted. Yeah, usually the input array is not sorted, but this is rated medium given a one indexed array of integers called numbers sorted in non-decreasing order. Find two numbers such that they add up to a specific target number. So the input is a sorted array of numbers and a target number. So let's see. Find two numbers. Okay, so these two numbers will be numbers at index 1 and numbers at index 2. Index 1 will be greater than or equal to 1. Index 2 is greater than index 1 and less than the length of the array. Return the indices of the two numbers, index 1 and index 2, added by 1 as an integer array. Let's see, what? Return the indices of the two numbers, index 1 and index added by 1 as an integer array. I'm going to look at an example here as an integer array of length 2. Tests are generated such that there is exactly one solution and you may not use the same element twice. Your solution must use constant extra space. Yeah, that makes sense. Okay, so here's an example. Numbers 2, 7, 11, 15. And the target is 9. This is example 1. The output, oh, I see, 1, 2. Okay, so when they say added by 1, what they're saying is remember that it's a one-indexed array. So even though as a Java array, these numbers 2 and 7, which add up to 9, would be index 0 and 1, what we want to return is actually 1 and 2. All right, numbers length, 3 times 10 to the 4th, 30,000, numbers length. So it's between 2 and 30,000. Okay, so that makes sense. There always will be at least two numbers, and there always will be exactly one solution. Okay, so let's look at how this might work. All right, so here's an array of numbers. This is not one of the examples, but the examples that they have here are a little bit maybe too simple. We will put a pointer here. Maybe I can do it in a different color. You know what? I'm not going to worry about that. But let's do a pointer here and here. We're going to put a pointer at the first element and the last element, and we're going to add them together. What is our target number here? Let's take a target number of 10. Okay. And then add the numbers together. All right, so we have 1 and 11. It's too big. That's 12. If the number is too big, we're going to decrement the pointer, the second pointer, the pointer at the end. Decrement it. So now it is here. Add the numbers. 8 and 1. It's too small. So we will increment the pointer over here. Now it's 3. 8 and 3 is 11. Too big. I'm sorry. Yeah, too big. So decrement the higher pointer here. Now it's 6. 6 plus 3 is 9. Too small. Decrement the smaller pointer. And we have 6 and 4, which equals 10. Okay, good. If the pointers meet, then there is no solution. But in this case, we would return, let's see, those are at index, really, I mean, array index 0, 1, 2, and 3, but it's a one indexed array, so it's going to be 3 and 4. We'll return an array with 3 and 4. Okay, let's see what the code would look like here. We need 2 pointers. So let's call one left. The left pointer will be initialized at 0, and we'll have another pointer called right. And we'll set that to numbers dot length -1. Okay, and now a loop. Whoops. Wow. Left is less than right. Now we're told that there will always be exactly one solution, and so we really, I think, don't have to handle the case where left is not less than right, but I think we kind of do, because otherwise Java is going to complain that there isn't a value returned for every possible case. So let's go ahead with it like this, and we'll say int sum equals numbers left plus numbers right. And then check the result. If sum equals target, we are done. So we can return an array of left plus 1 and right plus 1. Else, if let me think about this for a second. Yeah, I don't really like that so much. I mean, if we hit the target, it's going to return. So let's just do another if statement. If sum is less than target, sum is less than the target, we need to increment the left pointer. And if it is greater than the target, which is the only other option, then we will decrement the right pointer. All right. So anyway, this case should never happen, but if there is no solution, then we'll return an empty array. Actually, the description here doesn't even say what to return if there's no solution, because there should always be a solution. So anyway, that looks okay. Let's try it. Compile error. Return. Oh, I can't do that? Okay. Okay, I thought I could do it that way, but I guess not. So let's try this. New int array, and initialize it with left plus 1, right plus 1. Yeah, I think that'll work. Okay, let's try that. Oh. Right, okay, so it's not going to work down there either. In that case, let's just say return new int, I don't know, 2. All right. Basic cases run. Submit. Enter. Okay, good. Uses a lot of memory. Speed is good. I mean, it's just a two-pointer thing. So it looks like pretty much everybody gets gets the same result on the time. Anyway, sorry about the confusion on the array literals, but that is the two-sum solution. I'm sorry, two-sum 2 sorted array.